Today we are going to learn about efficient data handling with Python dictionaries. We will delve into techniques for optimizing dictionary use, enhancing data manipulation skills, and improving performance in Python applications.
Welcome to our video on efficient data handling with Python dictionaries. In this session, we will uncover the power of Python dictionaries, exploring advanced techniques for managing data efficiently. Python dictionaries are a fundamental part of data handling, providing fast access and manipulation capabilities. Throughout this video, we will discuss how to optimize dictionary usage for large datasets, leverage dictionaries for quick lookups, and compare their performance with other data structures. By the end, you'll have a solid understanding of how to enhance your applications using Python dictionaries effectively. Dictionaries in Python are built upon hash tables, a powerful data structure that allows for average one-time complexity for lookups, insertions, and deletions. At the core of a hash table is the hashing function, which maps keys to hash values, determining where the corresponding value is stored in memory. Understanding this mechanism is crucial for appreciating dictionary performance. Unlike lists, which require O(n) time for lookups, dictionaries offer a significant speed advantage by allowing faster access to data. This efficiency is because dictionaries store data as key value pairs, where each key is hashed to a unique index, enabling quick retrieval. This structural advantage makes dictionaries an ideal choice for scenarios requiring frequent data access and manipulation. However, it's essential to be mindful of hash collisions, where two keys produce the same hash value, potentially causing performance degradation. Python handles collisions gracefully by using techniques like chaining, but it's still wise to choose unique and immutable keys to maintain optimal performance.
Selecting the right keys for your dictionary is vital for ensuring optimal performance and avoiding potential pitfalls. Keys in Python dictionaries need to be immutable, such as strings, numbers, or tuples. This immutability ensures that the hash value generated for a key remains constant throughout the dictionary's lifespan. Unique and appropriately chosen keys can significantly reduce the likelihood of hash collisions, which can degrade performance. When two distinct keys hash to the same value, it can lead to additional computational overhead. To minimize this, ensure that your keys are diverse and not prone to collision. Additionally, consider the nature of your data. Choosing keys that reflect the unique attributes of your dataset can enhance the efficiency of data retrieval and manipulation. By adhering to these best practices, you can leverage Python dictionaries to their fullest, achieving fast and reliable data access. Handling missing keys gracefully is a common challenge when working with dictionaries. The defaultdict class from the collections module provides an elegant solution by automatically assigning a default value to any key that does not exist in the dictionary. This feature eliminates the need for explicit checks for key existence, thereby simplifying your code and reducing the risk of encountering a key error. With defaultdict, you can specify a factory function that generates default values. For instance, using int as the factory function initializes missing keys with a default value of 0, making it ideal for counting occurrences. This functionality is particularly useful in scenarios involving aggregations or frequency counts. By leveraging defaultdict, you can streamline your code, enhance readability, and ensure your data handling processes remain robust and error-free. Merging and updating dictionaries are common tasks when dealing with data from multiple sources or when needing to augment existing datasets. Python offers several ways to merge dictionaries efficiently. The update method is a straightforward approach that adds key value pairs from one dictionary to another, overwriting existing keys with new values. Alternatively, the union operator, vertical bar, introduced in Python 3.9 allows for a more intuitive syntax to merge dictionaries, creating a new dictionary with combined entries. When merging, it's crucial to consider how to handle conflicts where the same key may exist in multiple dictionaries. Define clear strategies for resolving these conflicts, such as prioritizing values from a specific dictionary or applying custom logic. Understanding these methods and their applications will enable you to manage and integrate data seamlessly, enhancing your data handling capabilities.
When it comes to quick data lookups, dictionaries are unmatched due to their average O(n) time complexity for accessing values. This makes them significantly faster than lists, which require O(n) time complexity for lookups. The key value structure of dictionaries is ideal for scenarios where real-time data access is crucial, such as fetching configuration settings or accessing user data in web applications. Consider a scenario where you need to check if a certain configuration exists. Using a dictionary allows you to perform this check almost instantaneously. In contrast, a list would require iterating through each element, which becomes inefficient as your dataset grows. By leveraging the power of dictionaries, you can ensure that your applications remain responsive and efficient, even under heavy data loads. Choosing the right data structure is critical for optimizing performance in your Python applications. Dictionaries, lists, and sets each have unique characteristics that make them suitable for different use cases. Dictionaries excel in scenarios requiring fast lookups, insertions, and deletions due to their average O(n) time complexity. Lists, while versatile, fall short in lookup performance, often requiring O(n) time. Sets, like dictionaries, offer O(n) average time complexity for lookups, and are ideal for membership testing but do not store key value pairs. When deciding which structure to use, consider both time complexity and memory usage. Dictionaries and sets can be more memory intensive than lists due to their hashing mechanisms. Understanding these trade-offs will enable you to select the appropriate data structure based on your specific requirements, balancing speed and resource utilization effectively. As datasets grow in size, optimizing memory usage becomes increasingly important. Python dictionaries, while efficient, can consume significant memory due to their underlying hash table structure. One strategy for minimizing memory footprint is to avoid redundancy by ensuring that data is stored only once. This can be achieved by reusing existing objects or utilizing shared references for identical values. Additionally, consider using compact data representations, such as tuples instead of lists, or leveraging data compression techniques where applicable. Python's memory management system, which includes garbage collection, can help manage memory automatically, but being conscious of these strategies enables you to further enhance efficiency. By optimizing how your dictionaries handle memory, you can maintain performance even when dealing with large datasets, ensuring that your applications remain responsive and resource efficient. To illustrate the power of Python dictionaries in data processing, let's examine a few real-world case studies. Consider a data analysis project involving customer transaction data. Using dictionaries, analysts can efficiently aggregate and analyze transaction details, such as calculating total purchase amounts or identifying frequent buyers, with minimal computational overhead. In another case, a web application may leverage dictionaries to manage user sessions, enabling quick access to user-specific data stored as key-value pairs. These examples highlight how dictionaries facilitate handling large datasets, providing fast access and manipulation capabilities. By adopting these practices, you can achieve significant performance improvements and streamline your data processing workflows. Each case study underscores the versatility and efficacy of dictionaries in real-world applications, offering valuable lessons for optimizing data handling in Python. In conclusion, Python dictionaries offer powerful capabilities for efficient data handling, providing fast access, manipulation, and storage solutions. By understanding hash tables, selecting optimal keys, and leveraging advanced techniques like defaultdict and merging, you can maximize the performance of your applications. We explored practical strategies for memory optimization and learned how dictionaries compare with other data structures, all while examining real-world case studies. We encourage you to further explore and apply these techniques in your projects to harness the full potential of Python dictionaries, ultimately enhancing your data handling skills and application performance.